Hello everyone, welcome to KS Math Academy. In this session, you will learn the most important questions in the chapter Applications of Derivative from class 12 CBSE. Look at the first question. Show that the function f of x 4x power 3 minus 18x square plus 2 is always increasing function on real number r. So you can find your first order derivative f dash of x is 12x square minus 36x plus 27. Take 12 common from the first two terms, then it will be, now go with this completing the square procedure. So x square minus 3x plus 9 by 4 minus 9 by 4 plus 27. So this is 12 times x minus 3 by 2 the whole square minus 27 plus 27. These two will get cancelled. So 12 times x minus 3 by 2 the whole square is greater than and equal to 0 for all values of x belongs to the real number r. So you can declare your answer f of x is always increasing function. Increasing function in real number r. Read the next question. If f of x is equal to x plus 1 by x for all values of x greater than and equal to 1, show that the function is an increasing function. Find the first order derivative. So f dash of x is 1 minus 1 by x square, and taking LCM x square minus 1 divided by x square. This is greater than and equal to 0 for all values of x greater than and equal to 1. So f dash of x is greater than and equal to 0. So you can say the function f of x is an increasing function. Read the next question. Find the interval in which the function is strictly decreasing function. Given function is. So find the first order derivative. F dash of x is 4x power 3 minus 12x square. Taking your 4x square outside, so it is x minus 3. To find the critical point, we have to equate the value f dash of x is equal to 0. So 4x square into x minus 3 is 0. So 4x square is equal to 0 or x minus 3 is equal to 0. So x is equal to 0. Here x is equal to 3. So our critical points are 0 and 3. So we have three intervals over here, minus infinity to 0, 0 to 3 and 3 to positive infinity. In each interval, we have to check whether our data function is decreasing function or increasing function. Our requirement is we have to find the decreasing function interval. So here we have to check for minus infinity to 0. In this interval, the f dash of x value is lesser than 0. So and again 0 to 3 interval, our data f dash of x is lesser than 0. But in the interval 3 to infinity, f dash of x is greater than 0. So we can declare our answer f of x is strictly decreasing function in the interval x belongs to the interval minus infinity to 0 union 0 comma 3. That's all. Coming to the next question, prove that y is equal to 4 sine theta by 2 plus cos theta minus theta is an increasing function in the closed interval 0 and pi by 2. This is 0, 0 and pi by 2. So y is here. So we have to find dy by d theta. So this you can take 4 outside. For the first term, we have to apply the quotient rule. So this is 2 plus cos theta into sin theta differentiation cos theta minus sin theta into sin theta differentiation. So while applying u by v rule, v u dash minus u v dash. So here it is 0 minus sin theta divided by v square. So 2 plus cos theta the whole square and minus the theta differentiation is 1. So now this can be 4 into 2 cos theta plus cos square theta plus sin square theta divided by 2 plus cos theta the whole square minus 1. So you can combine cos square and sin square is equal to 1. So our data is 4 into 2 cos theta plus 1 divided by 2 plus cos theta the whole square minus 1. Now you can take LCM for this item and take your 4 inside. So 8 cos theta plus 4 minus 2 plus cos theta the whole square divided by 2 plus cos theta the whole square. Now expand your 2 plus cos theta with a plus b the whole square formula. So 8 cos theta plus 4 minus 4 minus cos square theta minus 4 cos theta divided by 2 plus cos theta the whole square. So 4 will get cancelled. So the left out items are 4 cos theta minus cos square theta divided by 2 plus cos theta the whole square. Now again you can take cos theta in the numerator taking outside. So this is 4 minus cos theta divided by 2 plus cos theta the whole square. What is our condition? So here it is the interval is 0 to pi by 2. So here in this case we are involving with the cos item. So cos theta is greater than and equal to 0 in the interval 0 comma pi by 2. So we can say 4 minus cos theta is also greater than 0. So dy by d theta, the entire dy by d theta is greater than 0 for the theta belongs to the interval 0 comma pi by 2. So we can say our function y is increasing function in the interval 0 comma pi by 2. Coming to the next question, show that the function f of x 4x power 3 minus 18x square plus 27x minus 105 has neither maximum nor minimum. Find f dash of x. So f dash of x is 12x square minus 36x plus 27. So you can take 3 outside. So 4x square minus 12x plus 9. So 3 into this can be written as 2x minus 3 the whole square. So for finding the critical point, f dash of x should be equated to 0. So 3 into 2x minus 3 the whole square is equal to 0. So 2x minus 3 the whole square is equal to 0. So 2x minus 3 0. So x is equal to 3 by 2. Now this is our critical point. Now here is the sign of f dash of x is positive in the left and right of the neighborhood of our data. Then, so we can say the function has neither maxima nor minima. So you can declare your answer this way. Coming to the next question, find all the points of local maxima and local minima of the given function. First, find the first order differentiation f dash of x. So minus 3x power 3 minus 24x square minus 45x. Then second order f double dash of x minus 9x square minus 48x minus 45. To find the critical point, equate f dash of x is equal to 0. So minus 3x power 3 minus 24x square minus 45x is equal to 0. So our critical points are x is equal to 0, minus 3 and minus 5. So these are all our critical points. Now finding the local maxima and local minima. So at x is equal to 0 and your f double dash of x. So this value, if you evaluate your f double dash of x minus 9x square minus 48x minus 45 by substituting x is equal to 0, your value will be minus 45. This is less than 0. So you can say x is equal to 0 as point of local maxima. And similarly for x is equal to minus 3. So f double dash of x with x is equal to minus 3. And again if I am with here we are getting our answer as positive 18 and that is greater than 0. So you can say the x is equal to minus 3 is point of local minima. And similarly calculate for your next critical point, that is minus 5. So f double dash of x with x is equal to minus 5. then in this case we are getting our answer lesser than 0. So we can say x is equal to minus 5 is a point of local maxima. That's all. Coming to the next question, find the absolute maxima and minima of the function f of x is given in the interval 1, 5, closed interval. So find first order derivative f dash of x. So this is 6 into x square minus 5x plus 6, and here you can take your data 6, and within this data you have to find the factors. So x minus 2 into x minus 3. So here to find the critical point f dash of x is equal to 0. So our points are x is equal to 2 and 3, and this fall within the interval, given interval 1, 5, closed interval 1, 5. We are asked to find the absolute maxima and absolute minima value. So you have to calculate f of 1, the given data f of 1. So this is while substituting x is equal to 1 in our given function f of x, then the answer is 24. And similarly, f of 5 we have to calculate the given data. So f of 5, x is equal to 5 in this case, then our answer is 56, and our critical points 2 and 3. So f of 2 is 29 and f of 3 is 28. So among this, which one is the maximum value? That is our absolute maxima. So absolute maxima is, among this 56 is the greatest one. So 56 when x is equal to 5. And similarly, find the minimum value. Absolute minima value is 24 when x is equal to 1. Look at this question. It's a famous question. A rectangular sheet of tin 45 cross 24 is made into an open box by cutting off the squares of same size from each corner and folding up. Find the side of the square cut off from each corner for maximum volume of the box. So that is very important. So you can imagine this diagram. So let x centimeter be cut off from each corner. So our length will be 45 minus 2x, and our breadth will be 24 minus 2x. Now, here we have to calculate for maximum volume. So, volume of the box. So, volume is equal to V is equal to length breadth into height. So, our length is 45 minus 2x, and our breadth is 24 minus 2x, and our height is x. So, after multiplication, bringing it to a polynomial, so you will get your answer as 4x power 3 minus 138x square plus 1080x. So now you have to find dv by dx. So dv by dx is 12x square minus 276x plus 1080. Now again, to find the critical point, to equate your dv by dx is equal to 0. So our critical points are here the 12 into x square minus 23x plus 90 is equal to 0. So we can get your x value as x is equal to 18 or x is equal to 5. So among these two values, you have to check the suitability. So if we are considering x is equal to 18, then our breadth value, what is our breadth? 24 minus 2x. So 24 times minus 2 into 18 will be a negative value. So the breadth cannot be negative. So you can ignore this value. So you can take this x is equal to 5. This is a suitable value for the critical point. So you have to consider x is equal to 5 as our critical point. Now find the second order derivative. Our second order derivative is d square v divided by dx square is equal to 24x minus 276. So now you have to check the value of x is equal to 5 here. So d square v by dx square with x is equal to 5. So 24 times 5 minus 276. So 120 minus 276 is less than 0. So you can say the volume is maximum with x is equal to 5 centimeter. That's all. Coming to the next question, surface area of a balloon spherical in shape when air is blown into it increases at the rate of 5 mm square by per second. So ds by dt is given 5 mm square per second. So this is one of our given data. When the radius of the balloon is 8 mm, so r is equal to 8 mm. Find the rate at which the volume of the balloon is increasing. So these two are our given data. What is asked? So find the volume, find the rate at which the volume of the balloon is increasing. So dV by dt at r is equal to 8. So this is our question. So we know the formula, the surface area of the sphere. So 4 pi r square. So from here you can find your ds by dt. So which is equal to 8 pi r into dr by dt. So it is given as ds by dt is given as 5 in this case. So equate this value. So from this you can find your dr by dt value as 5 divided by 8 pi r. So you can use in the volume calculation. So volume of the sphere formula is 4 by 3 pi r cube. So dv by dt is 4 pi r square into dr by dt. For this dr by dt you can use this value. So 4 pi r square dr by dt is 5 by 8 pi r. If you simplify this data, this is 5 by 2 into r. What is our requirement? dv by dt at r is equal to 8. We have to calculate. So dv by dt at r is equal to 8. So 5 divided by 2 into 8. So this is 20. Here the unit given in the question is millimeter square, millimeter and second. So here since it is volume, you have to write millimeter cube per second. This is our answer. Moving on to the next question. The median of the equilateral triangle is increasing at the rate of 2 root 3 centimeter per second. Find the rate at which its side is increasing. So here it is given as, if you consider your data, H will be the median. So in the case of equilateral triangle, median is same as the altitude. So this is nothing but our altitude. You can say it this way. And x will be the side of the triangle. Side of the triangle. So now here we are given with the rate is, the median of the equilateral triangle is increasing at the rate of 2 root 3. So we are given with the data dh divided by dt is 2 root 3. So this is our given data. Now find the rate at which its side is increasing. So x, we are treating x as our side. So we have to find the data dx by dt. So in the case of equilateral triangle, height will be equal to root 3 by 2 into x. So from here you can calculate your x value as 2h divided by root 3. So you can find our dx by dt. So dx by dt is 2 by root 3 into dh by dt. And dh by dt is given with us 2 root 3. So you can substitute that value. 2 by root 3 into 2 root 3. So this is 4. So what is our unit here? Centimeter per second. Here x is also side. So you can say the side of the triangle ABC is, since it is positive, it is increasing. So increasing at the rate of 4 centimeter per second. Coming to this question, a wire of length 25 meters is cut into two pieces. One of the wire is to be made into square and other is made into circle. What should be the length of the two pieces? Show that the combined area of the square and the circle is minimum. So you can consider, let x meter and the total data is 25. So 25 minus x meter are required, our lengths. Our required lengths. So here one is square in shape, other one is circle in shape. So we know A be the side of the square and R be the radius of the circle. Now here, what should be the length of the two pieces so that the combined area of the square. So we have to find our A value and R value. For that, you first data is X and other data is 25 minus X. So 4 times A, the perimeter of the square, that is X, and perimeter of the circle 2 pi R is next piece 25 minus X. So A is equal to X by 4 and here R is equal to 25 minus X divided by 2, 2 pi. So now combined area is we want to calculate. So combined area is equal to capital A, that is area of the square plus area of the circle. So area of the square formula is side into side. So side is x by 4. So x by 4 the whole square plus here the area of the circle is pi r square. So pi into r value 25 minus x divided by 2 pi the whole square. So now you can simplify this data. So A is equal to x square divided by 16 plus here we are having pi into here in the numerator 25 minus x the whole square, in the denominator 4 into pi square. So you can cancel this pi and this pi. So our A value is x square divided by 16 plus 25 minus x the whole square divided by 4 pi. So now our requirement is the combined area should be minimum, we have to prove. So now we have to find our value dA by dx. So dA by dx is x by 8 minus 25 minus x divided by 2 pi. So 2 will get cancelled. So 2 pi here. So now you can take your data 8 pi as your LCM. So our data is pi x minus of 4 into 25 minus x. Now take your minus 4 and your 4 inside your data. So our data is dA by dx will be, and after taking your data x as common, so pi plus 4 into x. So pi plus 4 into x minus 100 divided by 8 pi. So this is our dA by dx. So for finding the critical point, dA by dx will be equal to 0. So our x value will be 100 divided by pi plus 4. So this is our data. For finding the next step, d square A by dx square. So here it is pi plus 4 divided by 8 pi. So differentiate your dA by dx one more time. So our answer is pi plus 4 divided by 8 pi. And this data is greater than 0. So our critical point x is equal to 100 divided by pi plus 4 is a point of minimum. So the length of the pieces, we want to calculate the length of the pieces. So length of the pieces, we are considering the length is one is x centimeter x meter and other one is 25 minus x. So first piece x value, so x is 100 divided by pi plus 4 meters and other piece is 25 minus x. So 25 minus x can be calculated, 25 minus 100 divided by pi plus 4. On simplification, 25 pi divided by pi plus 4 meters. That's all. This is our final answer. Meet you in the next video. Bye.